We're coming together to celebrate the past and dream big for the future. We are able to bring Denver Startup Week to this community thanks to our 2021 sponsors. Thank you to our HQ and title sponsor, Amazon, and our title sponsors, whose leadership makes this week come to life. Capital One Cafe, Downtown Denver Partnership, Fluid Truck, Hotel Engine, and WeWork. And our track sponsors, who have made all of the great content you're hearing today possible. Founder Track, Kickstart.
Hey, Zoe, we're having some technical difficulty, so I'm going to send it over to you.
All right, that's totally fine.
Yeah.
Oh, by the way, I did actually hear the sound the second time around.
Okay.
All right, so let me get this going. All right. Oh, you have to give me permission to share my screen.
Yep, one sec. Got it?
Yeah, I now see that I am the co-host. Perfect. All right, so let me go ahead and get this in presenter mode. Awesome. All right, I'm going to assume everyone can see my screen. I think I've done Zoom calls enough at this point. All right, so I'm Zoe Steinkamp, and I'm going to be doing the talk today for an introduction to time series databases. Real quick, I am a software engineer for Influx Data. We are the largest time series DB according to DB engines. I think we're ranked like number 22 in all the, I swear to God, there's like hundreds of databases in the world at this point. All right, there we go. So this is just a quick introduction about me. You can see a link to my LinkedIn if you want to go there. I put all the links like to the side in plain text because I wasn't sure in the presentation if you could really click on anything. I've been at Influx for over 2 years. Originally, I was hired on to be a front-end software engineer. I've recently moved over to being a developer advocate, which by recent, I mean approximately 2 weeks ago. It's very, very new. But before that, I was a software engineer for about 6 years, working mainly in the front end. I've worked in AngularJS and React mostly for my career. Originally, I was trained in Python because I really thought I wanted to do data science. I just landed myself in a front-end job instead. Outside of work, some of my favorite hobbies are traveling, cycling, cooking, gardening, snowboarding, skiing, rock climbing, everything that every, Coloradan really seems to love. And right here is a photo of my one and only pet, which is a snake named Snakey. She is named that because she doesn't care what her name is. She doesn't respond to it anyways. And we got lazy and just kept the name Snakey. She also occasionally is called Snakel. All right, so the key points that I'm going to go over in this are the basic components of a time series database. What is time-based data? I'm going to give a few examples just to kind of get your mind churning on that. What are the advantages of a time series database? Which for the most part, most time series databases in the market will have these advantages. And what are applications in the real world with real companies and also some pet project examples. All right. So when it comes to databases, most of us are pretty familiar with a relational and a NoSQL. And you might already be somewhat familiar with the time series. So we're just going to really quick go through these. So when it comes to relational database, you have Postgres, SQL, Oracle. Those are like the big three. There's many others, but we're just doing a broad scope. It requires a fixed schema, which as many of us know, you pretty much plan your database from the ground up. It's pretty much set in stone once it starts getting filled. You don't really want to change schemas. Databases are optimized for the tabular storage and related data in rows and columns, making it very searchable. A NoSQL is going to be MongoDB, Cassandra, and Redis. It does not require a fixed schema, making it very quick to scale. It works very well with large amounts of homogeneous data, and it has limited query capabilities. A time series database is going to share some of those same qualities as a NoSQL, but the difference is all of the data is timestamped. It's generated in regular metric and irregular event time periods, and it has huge volumes of data normally, and real-time and time sensitive. So here are some databases used for time series applications. So as you can see, a lot of people like to also use NoSQL databases when they're doing and dealing with time series data. They don't just use, just time series databases. All right, time series data, what is it? It is a sequence of data points typically consisting of successive measurements made from the same source over a time interval. So the easy one right away is weather conditions. This is something you probably ask Google every morning. What is the weather today? And she'll tell you it's going to look like this over the course of the day, over the course of a few hours. And she'll have, a picture of a sun or rain or snow. It's Denver, Colorado. This could all be in the same day, as we all know. Stock exchange, pretty straightforward on this one. You're watching the price go up and down over time, hopefully up. Cluster monitoring. Servers are on all the time, hopefully, without any outages. And so for the most part, they're constantly sending data in a time format. They're constantly saying, I'm up or I'm down, or I'm feeling sleepy, come help me. It snowed and we're all out of power. Healthcare. So I've actually worked before on getting Fitbit integrated into our platform. Healthcare is pretty much like Fitbit monitoring devices are pretty much all in time series data. It's all about what time of the day was your heart rate up? How long was it up for? When did you go into your deep REM sleep? All of this is on time scale. Logs. So logs are special in that they are not regular. So with logs, I like to always imagine a lot of us who develop, we have heat maps on our websites, which basically kind of track where people like to click, where they're touching, where they're interacting with, especially like buttons. With this, a log would be like the button. You log when someone clicks it at 2 p.m. and then at 7 p.m. But it's not consistent. It's not constant. It's random to an extent. The next day, 200 people could click on the button at 5 p.m. And it's the same concept with traces. Sometimes the response is quick. Sometimes the response is slow. Maybe you're dealing with messaging back and forth. It's not consistent. And that comes down to metrics, which are measurements gathered at regular time intervals. Just imagine them always running, always working. There's always weather. There's always hopefully a heartbeat. There's always a stock going up and down versus events which are irregular, measurements gathered at irregular time intervals. So those are just some little quick examples. So the advantages of time series databases. So with the input and output of data, time series DBs can ingest extremely high volumes of data to accommodate IoT and monitoring use cases. So especially when it comes to servers, they're very guilty of sending you a ton of data, so much data. And most of it you don't really care about. The main thing you care about is it working? Is it running? Or is it not working? Is it not running? And somewhat the same with IoT devices, though they're normally slightly less guilty of sending you huge amounts. Time series databases have solutions for expiring old, unwanted data. For example, you might only care about recent or real time and can afford to automatically delete that old data. Again, with server monitoring, you really only care if it's up or down. You kind of care if it was up or down yesterday, but it's not as important as if it's up or down right now today. Time series databases allow you to perform downsampling or create materialized views of your data. For example, you might want to summarize as averages, minimums, or maximums, rather than maintain the high precision data. So this is a great example of that weather before. You might really just care about the average for October, or the average first day of snow, or the maximum and minimums in a range for a month. You might not necessarily want to get into the nitty-gritty. Working with the data. So time series databases are commonly searchable on time. Go figure. This can be highly useful if you particularly care about the timestamp on your data. Because most time series databases focus on real-time data, they can be set up to create alerts and send notifications so you can take action. Again, this is the most common with IoT and server monitoring. If your server is down, a time series database will normally alert you. It can send you a notification, normally over Slack, email, PagerDuty, the normal places, and it can let you know that a threshold has been reached. You normally tell the database, hey, at this threshold, if it's at this duration for this amount of time, let me know. I want to be aware. And it's the same thing for IoT devices. You want to know if it's snowing outside. You just want to know if the temperature reaches below 32 and there's high moisture in the air. Maybe you're like a weather forecaster. That's important data to know. And then manipulating time-based data. So working with the time series DB is helpful with working across time zones, as the timestamp can be adjusted. For the most part, most people just work around UTC or a specific time zone. It can also make it easier for developers working across multiple time zones to read that data. As most of us are probably experiencing over the past year, as some of our coworkers move around, we have to deal with the loveliness of working in multiple time zones. Built-in functions for manipulating time, which I've already kind of talked about some of these, but they can include calculating durations, converting timestamps, calculate durations between events. Again, that button, you want to know how often people click on it. What's the length of time, that it goes silent? It's probably, during the night when no one's on your website. So this is a quick just data visualization of a time series data. So on the x-axis, we have our time. On the y-axis, we have the views of Peyton Manning's wiki views per year. So quick note, in 2011, you can see a spike where they were speculating his future with the Colts and then him signing with the Broncos. In 2013 was his first appearance at the Super Bowl. And finally, in 2015 was his final season and Super Bowl win. And obviously you can kind of also see where like the off season is as well, when he's not playing as much. So now I'm going to go into some real world examples. So I've already gone into this pretty much fully in depth at this point, so I didn't put a ton of words on here, but infrastructure monitoring, for all intents and purposes, is server monitoring. It's what I've talked about and used a lot of examples here. The big thing with server monitoring is you set up and you forget it. You set up the alerts, you set up the notifications. It's not so much for diagnosing problems in the past. It can be used for that. It has been, but it's more about, I want to know if my servers are healthy. If it goes over this amount, please let me know. And to an extent, it can be useful to see that your configurations are working. You set up something, you expect it to get larger, get smaller, give more storage space, give less storage space. And if it's not responding as you set it up, it might be helpful to find that out sooner than later. So this is a real company. This is a real example of IoT monitoring in action. This is a wind turbine farm in Europe. They're out of Antwerp in the Netherlands. And a wind turbine farm needs to make the most electricity it can within the confines of weather and laws of local government. To do that, they use IoT sensor data like temperature sensors, temperature forecasting, neighborhood scheduling, personnel scheduling to guide their turbine operation scheduling decisions within variable weather conditions. All of these sensors send in huge amounts of time series data, which need to be organized based on the time that they come in. So in this example, the wind turbines actually can't be running when in times of the neighborhood, the people need to get sunlight. It's just like a rule. You can't run the turbine and have, homes have no sunlight throughout the entire day. Also, turbines need a lot of attention. They need a lot of TLC. And that can't happen when it's snowing and everyone's off work. It just doesn't work that way. So you need to really keep in track all of these IoT sensor data. And for here, I put up a little photo of their turbine status dashboard, where they basically have most of them green, a few of them orange. That means they need some work. Maybe some of the IoT sensors are coming back with some concerning numbers, and they're going, oh, this looks concerning. We need to go check this out. Real-time analytics. So the biggest difference between real-time analytics and server monitoring is basically with real-time, you're actually really paying attention to the data coming in. This would be an example where you have it up on a TV screen in your office, a pretty graph that's running something. Or in general, maybe you're watching it in the background. So for this example, I like to use, not all of us can be as skilled as Mr. Gokes, the high rolling cryptocurrency investing hamster. Some of us need a bit more help to make investment decisions. Professional stock traders use time series databases to analyze stocks in real time. Although computers make the trades in the blink of an eye, it's humans who read the graphs and make predictions and set the parameters for those buys and sells. Though as we know, a lot of computers are starting to make those predictions too, but they also still read the data. So this is another company that's one of my favorites because I really like plants. I'm very guilty of liking plants. And I just think living walls are super cool. They also do this for golf courses, but I don't golf, so I had less interest in that part of it. But basically what they're doing is their data is normalized and analyzed, and key metrics and events are sent to a mobile application for customers to track the green wall health and decide when to take appropriate action to maintain plant health and irrigation systems. Customers are notified only when necessary. For example, if the pump fails, the light switch on, if a temperature suddenly drops. In addition, the data is combined with temperature forecast to predict and schedule future irrigations, making it possible to reduce the chances of overwatering. So yeah, these plant walls are pretty advanced. They're probably not super easy to manage and maintain, even for an advanced gardener. So these systems really help people. And obviously golf courses are huge and they take a lot of energy to, make sure everything's healthy and green and beautiful. And these devices are also used in places like football stadiums. Basically, wherever you can have an IoT device monitoring plants. And this is actually my home project example. So one of my own fun little projects is my Plant Buddy IoT monitoring device, which is an extremely small scale version of the living wall. It monitors my houseplants for their water, humidity, temperature, and light amounts. And it's mainly so I can bring back to life some of the plants that are failing to thrive. It's almost always overwatering, by the way. And as you can see, this is a graph showing two of those sensors, the light and soil moisture. Future applications. We cannot see into the future, but we assume time series will become even more integrated with IoT devices as the amount of sensor data increases with every new device in our home. As most of you are well aware, every single new appliance you bring home seems to have tracking and sensors in it to help you for the most part. And we can only hope to become more integrated into the future of chickens and VR headsets. This is actually, I took this photo like a month ago at the museum in Vienna of applied arts. And it's really cool to imagine in the future that chickens are going to wear VR headsets. So some ending notes and resources. So if you want to try out a time series database, there are multiple time series database companies you could choose to work with, but not all of them are open source, which can make it hard to test drive. Not every situation is even going to be ideal for a time series database. And it's best to have an option for a free and painless testing environment. InfluxDB has been open source since our founding in 2013, and we are dedicated to the open source community. We have a free tier on our cloud product, which you can find there on that little link right there. We also are the founders of Telegraph, which is completely open source. It's actually used by a lot of our time series competitors. And most of these plugins, which this is just a small amount of them, are actually managed by a lot of their plugin contributors. It's completely open source. Like I just said, we've been maintaining it for years. You can also use, we have a CLI, a VS Code tool, or our actual UI to add data. And here's some contacts. So my contact email, we have a community site or Slack where you can ask all the questions. I would know I'm sometimes on there answering them. If you have your own cool use case / example, you can actually get a free hoodie for sharing your story. We have a wide range of templates for quick sandboxing. And a lot of these are actually not really professional work ones. We have ones for Minecraft, I think CSGO, a few of those games. And you're welcome to join us for Influx Days, which is a free conference going over Influx and its use cases, which is a little bit later in the month. I just wanted to give a quick shout out also to Denver Startup Week for hosting this. It's great to get us all together, even if it's just virtual. I'm really, really happy that they always do this event. And that is the end of my sharing. I am going to go look at the questions here. Yes, so InfluxDB does have its own dialect version of SQL, which is known as Flux. We have a ton of documentation on it. And if you ever have any questions, you can easily just go to our community. We have a lot of people who basically give us SQL queries and ask how you would do that in Flux. Yeah, this wasn't a super in-depth presentation technology-wise. At least on our website, we have tons of blogs, tons of use cases, more code examples than you could ever read through, I can assure you. And this is really just to get people to start thinking about time series DB and some use cases you might not have really thought about. It's not necessarily to go into a deep dive per se. If anyone else has any questions, you can ask them in the Q&A, or you can ask them in the chat. And if not, I hope we all have a fantastic Monday and enjoy Denver Startup Week.